what's good? Alright, so this past week, maybe 2 weeks ago, I finished the Safecracker and Lockpick 2 Sherlocks from Hack the Box. And they were cool. Both had a very similar theme of needing to kind of understand some malware that was doing, it was basically just ransomware, encrypting files. And there were two things that I learned after doing them that would have made the challenges easier. And I wanted to share those for noobs like myself that are just finding out about these things. Um, so one of them was I was having an issue with debugging, and the first thing that I learned was how to patch binaries in ghidra. So I was able to get through the challenge using GDB and setting breakpoints and, manually kind of modifying values where I needed to get to the certain areas where I was trying to get to, in this instance, past a debugger. Um, but I was still wanting to use some of my debugging tools outside of that. And so learning how to patch a binary in ghidra and then coming back out and running a tool like ltrace on the patched binary was something that I thought was cool. So that was the first thing, and I'll go over a couple of different ways to do that. And then the second thing I learned about was this thing called the LD preload trick. And essentially that was my problem was once I was running ltrace on the binary, I was seeing a library that was being called, and I was seeing the places in memory for the values I wanted, but I wasn't able to see the values. And in this specifically in this instance, I wanted to see the key and the IV that were being used when the that library was called. And again, able to do it in GDB, but I felt like there was a better way to do it. And so that's what I'm hoping to show today. So in order to show these things, I've created two binaries that have some of the similar functionality that we saw in Lockpick and Safecracker. First thing, getting past the debugger. Second thing, seeing the values that are being used during encryption. So the first binary I made is just something called debug root and debug root flag. So it checks to see if a debugger is running and then if the user's root. If it passes both those checks, it will make a flag at root. So we can do sudo cat, and we see it creates the flag. The issue, of course, if I wanted to run ltrace on this, I would get processes being debugged. So that's the issue, that I want to be able to see what's going on here, but I can't because it's being debugged. So let's fix that. So what we'll do is we'll open up ghidra. I'm going to do this in the debugging. You could do everything through what everyone typically uses ghidra for, clicking on the little dragon, but I'm going to click the bug just because it's new to me and it's, maybe new to other people. And so same kind of thing, we got to import the file. Actually I have to open it because I've already imported it. We'll analyze it and go to main. Something that we're missing here that we typically get in the other ghidra view is this symbols tree, the symbol tree. And so just like normal, we'll go to main, see what's going on. Main super easy, we're already there. Is debugger present? And then if this value is 0, we're going to go to no debugger detected, and then we'll check we'll run this check if user is root. We could, of course, see what that's about. check if user's root, and same kind of thing. So we want to get here by just bypassing this first is debugger present. And so there's a couple ways to do this, but so the analogy I have is it's like a kid asking their mom if they can go to their friend's house, and their mom has a rule: you could only go to your friend's house if your room is clean. And so, being the young rebellious kid we are, we don't want to clean our room, we just want to go to our friend's house. And so the debugger is using this check, and it's going to proc self status, and it's basically looking for this tracer PID, and it's looking for what the value of this is. And if it's 0, it's going to say that that the debugger is not running. And we could see that if we go to console. We can go to cat proc self status, and we look for the value of the tracer PID, and we could see it's 0 here because this is not being ran as a debugger or with a debugger. We could do the same thing with ltrace, and here we go. And now we see that there is a debugger, so this has a value. So this wouldn't pass the debugger check. So we know that it's referencing this file, this proc self status. So what we could do, we'll see that we're being super extra in doing it, but what we could do is just create a different file that has that tracer PID, set it to 0, and just patch this binary to when it's looking for this this proc self status, we point it to the file that we control, and we again just make sure that PID is 0. So that'll be the first thing we do. We'll see again that this way is again super duper extra, but I think it's kind of fun. So we need to find where this is being stored. So we could see that this value is being stored here. And we can right click it, we can go to patch data, and we're gonna make this fake status be at home Cali, and we're gonna do one called fake us. And we see that this is updated. We see that it's updated here. All right, cool. So let's now go to File, Export Program, and we're going to do it as an original file, but we are going to put it on our desktop, and then we're also going to name it root flag, and this will be 1. This will be our first alternate. All right, cool. So we have that. What we don't have is we need to take this value that it's expecting, and we need to echo this to a file at home Cali fake us. And now we should go to cat home Cali. Okay, cool. So we have exported our flag, debug root flag 1. We can chmod just to make sure it's executable, and we do that. And so what have we done? Let's make a prediction. So we have attempted to bypass the debugger by pointing it to a different file. So everything should work similar when we debugger present, users not root. That's what we expect. No debugger present, user is root that time. All right, cool. But now what we want is what happens when we run ltrace and we get the no debugger detected, users not root. So now we were able to point um, that check, what tracer PID was, to a different file. So instead of looking at the self status, proc self status, we pointed it to the home Kali fakeus. Uh, and we bypassed it and we're able to run ltrace on it now. And we're able to understand some things like users not root. So if we did sudo, we could see, let's actually do sudo before. And now we're able to see the write and the open. And so again, we're able to see a little bit more. All right, so in our analogy now going back, what did we do? So little Timmy wants to go to Johnny's house. Timmy's like, Mom, can I go? She's like, send me a picture of your room. Timmy knows some guy whose room looks really close to his or similar to his, takes a picture and sends that to his mom. And so that's cool, but that takes a lot of work and we don't necessarily need to do that. Uh, we're running a debugger, we could do more than that. And so what else can we do? So the logic behind the mom's decision making, we could change that in the program. So right now the program is saying if you're a debugger, don't move on to the next step. We could change that to say if you are a debugger, then move on to the next step. And so what would that look like? I'm gonna exit out and I'm gonna open back up. Just so I don't want to change that flag back. And then we'll analyze it again. And then we'll go back to the window. We want that symbol tree. We're already at main, the debugger present. We want to see what's being called, and it's back to self status. Okay, cool. So let's go back to main though. So we're looking at this function being called. But if we go back to main, we could see that this check, it's calling the is debugger present, and then it's running this test, and it's saying jump at 0. And if it's 0, we're getting it to no debugger present. And so that means if it's not 0, we're going to this process as being debugged. But we could just change this. So we could go to patch instruction. Instead of jump at 0, we could do jump at not 0. And that will get us to where we want to go. And in our analogy, this is kind of like if we had a mom and we could say it was opposite day. So this is just flipping whatever the logic was for the decision before, we're just going to flip it. And we could even see that it's being changed up here. So if this var equals 0, process being debugged. If it's not, then there's no debugger. And so this is cool. So let's try this. This would be the second way to potentially get past this debugger is changing the logic. And we're not gonna have to create another file. We should be able to just run this with ltrace now. And this is desktop, that's cool. We'll name this 2 for variation 2. We should see that here now. And then we'll go chmod, we'll go 2. And now when we run it the regular way, we should see that the debugged because it's flipped now, right? But now we go to ltrace and it's not flipped. And again, if we did sudo, we would be able to see the additional steps that it's taking, the additional libraries it's using. And right now that's not interesting to us because we see the flag that it's making. But when we get to the encryption part, and if this function was actually encrypting our files, um, the next part we'll be able to use. All right, so that's cool. We've gotten past this two ways. First way, we know that it was referencing a file. We just changed what it was referencing, patched it. Cool. Second way is that we changed the logic. We said that whatever logic you wanted to get to the debugger if is present, we're going to flip that. That's cool. So I'm going to restart this again, and we'll go to a third way. And the third way is we can get to where we want to go. And like in our analogy, the mom, Timmy asking if he could go to his friend's house, we could just go straight to the friend's house. We don't even need to ask our mom if we could go. We could just go. And how do we do that? So yeah, we're gonna analyze it again, cool. Back at main, we know we want to get into the check if users root. We know we want that to be called because we know we want this create flag in root. This is the thing that we're really caring about. In the ransomware example, it will be the actually encrypting of the files. Here we just did the creating of the files to make it easier. So we'll look into this create flag in root. And the thing that we kind of care about is that this is the function that is being called. So it took a while to get here, but this is the actual function that's being called once we get here, is this create flag in root. Why don't we just call this as the first thing that's being called? Why do, instead of allowing the program to ask if the debugger is present, why don't we just call this? And so we'll do that. And we want the table, the tree, just to get back to the function. So we need to go back to the main. And we see that this is the first thing being called. Call debugger is present. So we want to patch this, debugger being present, to call create the flag. Because we know it's the first thing, let's just get it all over with and get to where we want to go. So we can patch this. Patch instruction. And we go to patch it and we see that it's calling this hex value. We can't just put the name of it. So what is this hex value? 11E9. So let's go find out what that is. So is debugger present? Let's go here and let's look at this, and we see here is that 11E9. So the start of the instruction right here, 11E9, is for the is debugger present. What do we want? We want create flag in root. So we'll go to that same spot. We see it's 12E3. We want to copy this, go back to main, go to where this is being called. Now we can patch it with this value. All right, cool. And we can file a third time, so char export program, and this time it's 3. Cool. So we should see that here again. LCH mod again. And now when we run this, the third one, we just get a permission denied. So it's just trying to print that flag, but it can't because we actually don't have permission. As the cal user, we don't have permission to do that on the root. So let's sudo, it creates the flag. But again, we could have done this before. The thing we really care about is the sudo ltrace debug 3, and we see it does it again. So that would be the third way. So we could understand where that value is coming from, direct it to a different value of our control, way number one. Number two is just to flip the logic of the function. And number three is to just call that function right off the bat. That if we can call this and manipulate everything, if we care about a function, we can just call that straight from what we're, you know. And so that's the first thing, just patching a binary. And that was useful for me because once I patched the binary, I was able to see more of what was going on with my typical debugging tools. So let's see where this comes in using ltrace. So I'll get rid of all these. The second thing that I care about is, or the second binary that we're going to be working with is an encryptor binary. So I could go to, it's on my GitHub, I'll put this somewhere. But this is the encryptor code. And we will nano do that. And then we need to compile it. Alright, and then here we go. So we will give it the execution privilege for the encryptor. And the way that this one works is that you put in a file and then it will encrypt it for you. So we'll echo hi, let's go hello, it's a hi.text, and then we can run encryptor on it, and we'll go to hi, and we will output, we'll do that. So we cat hi.text, just to make sure everything worked right. We cat hi.encoded or encrypted, and see that's encrypted. This one does not have any checks, so we could have also ran encryptor with ltrace here. And this is the issue that I had before, where now I'm able to see ltrace. I'm able to see, I know this function, these functions well enough to know that the key and the IV are going to be in them. And during the initialization of the encryption. So the issue is that I was able to see the functions that were being ran, but I couldn't find a good way to see the values for the key and the IV. And so this works because this is a dynamic library. When the binary is calling these functions, it's asking to kind of use them from my host system. At least that's the way that I'm understanding the difference between static and dynamic binaries in this sense. This saves the binary space. If it knows that it's going to need a complex function and it knows my system's already going to have it, it can just call the function from my system. And so we need to set up a way where we can see what these values are. And that's the beauty of this LD preload trick. So what this does is, we'll use a different metaphor now. So say that I'm going to the gym all the time, and the weights don't have values printed on them like they typically do at the gym. And say I see some other guy and I'm curious how much weight he's lifting, and I can't just look over and see the value printed on the side. I see that he's moving, like I see the action happening, but I don't know how much weight it is. And so with a dynamic library, it's like going to the gym. You don't bring your own exercise equipment to the gym because you know that the gym is going to have a lot of those things for you. And so, that's why you go to the gym. And static binary would be like going to the park where you like might need to bring your own basketball and jump rope to the park or like whatever you're planning on doing. You don't need to bring those things to the gym a lot of the time though. So going back to my example, what we're doing with the LD preload trick is we're using a hook to essentially kind of stand in the middle and offer our library to the user, and we take in that info and then pass it to the system, right? Because you have the program that's running and it's calling the libraries, and then it's got to pass that information to the processor, kernel, or whatever it's actually doing the computations. Um, and so we could almost set up like a man in the middle where we offer our library, capture those numbers, and then just push everything through. So the weight analogy would be, say one day we brought all of the dumbbells, like for all of the dumbbells at the gym, we brought our own set. And when the guy was ready to use dumbbells, we told him, hey, I brought some dumbbells, you could use them if you want. And the guy was like, all right. And so he used my dumbbells, but because they were my dumbbells, I know exactly the weight, the value. Um, and so there was like, I don't know. Key thing is though that we get the information, we get the actual values. We don't get just these pieces of memory. So let's do that. That was a big explanation. Let's just do it. All right. So the value that we'll need, or not the value, but the first thing that we'll need is to create this hook code. So we can do this knowing these open SSL libraries are being used. So let's nano hook.c. Let's not do that. Let's do that. We're going to need to do this to compile it. Save it. We'll compile it. So we have that now. And now what we could do is, before we were running the encryption, it was working, we'll throw it away. Didn't need to do that, it was going to override it, but whatever. And we'll use this preload trick. And so we're going to put in our hook and the encryptor. That's not what we want. And the input is again hello.txt. And then our out is going to be again hello.enc. No file. How did I mess this up? Unable to open input file. Oh, it's hi.txt, the input file. Alright. That hurt my brain. But, alright. But it works. So now, instead of seeing the memory, we're able to just, intercept these values. And so we can just run a check to make sure this works. Cat or hi encoded again. just to show that it is encrypted. Not alright, cool. So let's open SSL code. Oh, code. And then this was AES 256 CBCD. For our in, we're going to use the encoded. So this is going to be high or encrypted. Our encrypted, and then our out is going to be, we'll call this final text. Probably a better name for that. For a key, we'll copy and paste the key that we got from our hook. And for our IV, we'll get this one too. We'll run this. We see final pop up, cat final. And there it is. We got it. So that's it. Two methods I learned for, I guess, two tricks for dynamic analysis. One is to patch a binary so I could actually use more of the programs that I'm familiar with and not be in GDB. I was able to do it all with GDB, but it just felt clunky at some points, and I wanted to bypass some things. So the patching helped, and then this preload trick I think is cool, and I think that it could be useful for more than just the encoding or the encryption, calling that OpenSSL, the library. So it needs to be dynamic. That's one of the kind of downsides to it. But yeah, that's it.